So now we'll also do number 14 on this same page, page 545. And this one says to find the component form. Find component form. And that means we want this. This is component form up here. So we can call this the component form of the vector. All right, because it shows the x component and the y component, and that's really what we need in order to be able to analyze them. And then, so number 14 says your your vector has magnitude 13. So they don't say this explicitly, but the magnitude is 13, and the direction is 200 degrees. All right, so we just use this formula, these formulas here's, right? Vx is magnitude v cosine theta, and there's no tricks to it. That you don't have to worry about quadrants or anything because you're not using an inverse function. So it's just Vx equals 13 cosine of 200 degrees, and Vy equals 13 sine 200 degrees. And just a reminder, you know, vector work likes degrees and every other mathematical process likes radians, so be aware of what your calculator is set in. So just check, oh yeah, I can see it's in degrees. All right, so I just go 13 cosine 200, and that's negative 12.216. So yeah, I mean, there's probably a, I could probably do like a radical on that, but I don't feel like it. And then 13 sine 200. This is probably all we have to do. Negative 4.446. Negative 4.446. I don't really recognize those numbers anyway. So then your component form of the vector is to write it with the, you know, these angular brackets, negative 12.216, comma, negative 4.446, and that's your component form. All right, beautiful. Now, the next thing they ask you to do is do some sort of basic operations on them that are like really easy to see. So, I guess I do need to mention that, well, let's actually do this in the context of the problem. So I'm going to look at number 22 on this page. So in number 22, they give you two vectors, and notice what they do for vectors is that they use a boldface variable to represent a vector. A lot of books do that, boldface to represent a vector. You have to just look at what the book's doing. So I'm going to write it with the vector hat. So we have vector u equals 3, negative 2, and vector v equals negative 2, 5. And we are asked to find what is negative 2u plus 5v. So these are the things you can do with vectors. You can multiply them by real numbers, and you can add them. So you can also do other things like subtract them. There's two different kinds of multiplication of vectors, vector times vector. Yeah, lots of things you can do with vectors. All right, but this is not a course on vectors. So in the context of vectors, by the way, a real number is called a scalar. Scalar, S-C-A-L-A-R, and with the idea that it scales the vector. So for example, if I do scalar multiplication, just to like take a simple example, let's say I had the vector 2, 1, right? So here's 2, 1. So here's the vector 2, 1, right? So if I multiply that vector by 4, okay, then that's going to equal the vector 8, 4. So what you end up with is the same vector but larger. So it just scales the vector up. So this is called scalar multiplication. All it means is you take the components and multiply them by whatever real number you're multiplying by. So we say the scalar 4 times the vector 2, 1 is equal to the vector 8, 4. So, you know, scalar basically just means a real number. Those scalars are real numbers. All right. So, but how to work that with them is like it's pretty insanely obvious. So for this one, I'm going to go negative 2 times the vector 3, negative 2, plus 5 times the vector negative 2, 5. All right. So I just multiply the components. So I have the vector negative 6, 4, plus the vector negative 10, 25. And then to add vectors, you just add them component-wise. Negative 6 plus negative 10 is negative 16. So I get the vector negative 16, 29. So you can probably get the idea that if I have two simple vectors, like let's say I have let's stick with 2, 1. All right, 2, 1. Here's 2 and here's 1, and then I have another vector. Let's say my other vector is 1, 2, 1, 2. All right, here's my other vector. So we'll call this vector A and vector B. Then I get vector A plus B by basically taking this vector and sticking the tail of this vector onto the head of that one, and then just go up 1 and over 2. All right, so I'm going to go over 1 and up 2 because that's this vector. So then I just add the components. So my vector A plus B is here. I mean, I don't want to do a whole course on vectors, but this is the vector A plus vector B. All right, so vector A plus vector B is equal in this case to 2, 1 plus 1, 2. You just add the components. It's 3, 3. So that's vector addition. So what we're looking at here is vector addition and scalar multiplication. So, hopefully it makes sense. If I go over 2 and up 1, and then I go over 1 and up 2, altogether I've gone over 3 and up 3. So it works pretty simply. All right, so that's your number 22. All right, next up we're going to consider functions of vectors, and then we can talk about velocity, acceleration, and speed. So then we will start calculus. None of this is calculus yet. Calculus starts in the next video.